Hi everyone, in this video we're going to go through some of the challenging questions from the 2019 VCAA exams, focusing on networks. Okay, so for the first question here, we're looking at question 6 in the multiple choice exam 1. So this question, only 39% got the right answer of A. And so the first thing that we want to be looking at is some key features of the graph that we've been given. So we have this map looking at 5 towns and the roads connecting them, and we're wanting to translate that into an adjacency matrix. So the tricky thing here is that this map is not drawn as a network diagram would be. So we can't clearly see multiple edges and any loops that are occurring there. So the first thing that we would want to do is what are some distinguishing features? So firstly, if we look at the adjacency matrices that we're given as the options, we're checking to see what are some key things here. So we can see some of the graphs have, some of the matrices have a loop. So remember, any value in that leading diagonal would be considered a loop. Okay, so if we just take E as an option there, we can see at the moment they're saying a loop would be at vertex P and another one at vertex S. Okay, so let's see if there are actually any loops in this graph. And a loop would be I could leave a town and return to it without passing through any other town at all. So if I take P as the example, I can leave town P, drive around and back in without passing through any other town. So it's at least one loop that I can see there. Okay, and so we're just checking, is that possible from any other towns, and is there multiple ways of doing it? Now remember, coming out, I guess, towards the left-hand side and driving back in is the same pathway as leaving from the right and driving back in. It's actually the same path that we're following, so it's a single loop that we're seeing there at P. If we wanted to check some of the other options, so a loop at S, we can see that that's not possible. I can leave S, but I cannot get back without passing through a different town. Okay, so just by looking at that option, I want to knock out any of the questions that have a loop anywhere else except for at P. Okay, so option A, there's only a 1 in the diagonal of P, so that's possible. Option B, again, possible. Option C has no loops at all, so it can't be C. D only has a loop at vertex S, so not possible. And E, again, has that additional loop at S. So then between option A and B, what are the differences? Well, the first thing I can see is that it's telling us that from Q to P, there are 3 different pathways. So if we have a look whether it's possible to get from Q to P 3 different ways. So I guess firstly, I could go across here. So that's one clear, obvious pathway. I could come out here. That's another clear, obvious pathway. But we need to check, is there 2 or is there 3 pathways? And I can actually see that I can, if I just change that color so it makes it a bit easier to see, I can come out of P along this road and then into Q. And that actually gives me a 3rd option there. So for that reason, I would be saying that A is my answer, which we can see is the correct answer there. So I haven't had to necessarily go and do the whole adjacency matrix. I'm just looking for those key features. And the easy ones to look at in an adjacency matrix are loops and multiple edges. Okay, the next question here, we're given a precedence table for a project. So we've got 9 activities A to I, and we can see the immediate predecessor of each activity there. And so a directed network for this project will require a dummy activity. And a dummy activity is going to be drawn from where? So remember, with your dummy activities, you're looking in your precedence table at any activity that appears in multiple parts, okay, or as multiple predecessors. And so where you've got A reoccurring here, that's okay, because that is paired. So A is on its own as one predecessor, and it appears again on its own as a predecessor. We can see the same for D. D appears in two things, but it's just D on its own. It's matching there. Whereas here, we've got activity B on its own as a predecessor for activity D, but then B and C as predecessors for activity E. So where I've got this mismatch occurring, I know that that's telling me I need a dummy edge, okay? So firstly, I do know, yes, I need a dummy, okay? So how do I know which activities to relate it to? The activity that is showing up in both, so activity B, the dummy needs to start at the end of activity B, okay? And then it will connect into the activity that has the mismatch. So in this case, it will connect into activity A. And so then we can see from our options here, option B, activity B to the start of activity E is our best option. Okay, so question 8 here, we've been given a project network, the directory graph, and showing the sequence of activities A through to S, so quite a few activities there. The time taken to complete activities shown as well. And so the question is asking us, what are the number of activities that have a float time of 10 hours? So remember, to get your float time, you're talking about the difference between your latest start time and your earliest start time. And so in order to work that out, we're going to need to do a full forward and backward scan so that we can see each of those values for all of our activities shown. Okay, so I've gone ahead and done a full forward backward scan, and I've also highlighted the critical path just so we can see definitely what activities not to include. So of the ones left, we need to check all of the float times and see if we can identify any that have a difference of 10. And so remember, the key thing is we're looking at the latest start time, the red numbers on the outside of the box, and comparing that to the green number inside the box. So if I look here at activity G, we can see latest start time of G is 16, earliest start time is 6, so we have a difference of 10 there. So one possible activity, G, has a float time of 10. Okay, and working our way through any of these non-critical activities. Okay, so H has a difference of 3, that's okay. C has a difference of 3. L has a difference of 3. G we've already identified. Okay, F has a difference of 4. M has a difference of 8, so that's okay. Doesn't meet our criteria. Up the top here, I has a difference of 10. So again, I fits our criteria, has a float time of 10. N has a difference of 10, 39 minus 19, so N. P has a difference of 2, R has a difference of 2, and that completes all of our non-critical. That means we've got 3 activities with a float time of 10. So that is a time-consuming question, and once you've done all of that work, the other complicating factor is that you have to check all of those float times and make sure you're looking at those correct latest start times and not just the number that's in the box. Okay, the next question here is taken from exam 2. This is actually question 2, part B. So here we have a school medley relay team, 4 students, Anita, Imani, Jordan and Lola, and the race is 4 different distances, so 100, 200, 300 and 400 metres in that order. So the table shows the best time for each student's sprinting each distance. So we can see that there. The school will allocate each student to 1 sprinting distance in order to minimise the total time taken. Which distance should each student be allocated to? And we want to pop our answers below. So this here, we're looking to use the Hungarian algorithm to minimise that allocation of tasks. Okay, so if we think of each person and each distance as one of the jobs that has to be allocated, and so here we're looking to do that row and column reduction and then checking how many possible allocations, checking for crossing out of zeros and seeing what else we need to do from there. A key thing to note, your row reduction and your column reduction can actually be done in any order. We tend to do rows first and then columns. But if we were to do rows first in this case, all of our zeros would be in the 100-meter column, okay? And so if we can see that something like that will happen, it actually can be better to do a column reduction first up. So that's what I'm going to do here, okay? So if I look at this whole first column, I can see my lowest time is 13.3. So I'm actually going to subtract 13.3 from everything there into my first column, okay? And so when I do that, if I just do it off to the side here, I get 0, I get 1.2, I get 0 again, and 1.9 as my first column there. And then again, moving across, so the 200 meters, this lowest time here, 29.2. So I'm going to subtract 29.2 from everything in that column, and I end up with 0.4, 0.4, 0.1, and 0. Working across to the 300 meter column, so the smallest value there, 61.6. I subtract that again, 0.2, 1.9, 2, and 0. And then finally, the 400 meter column, so subtracting 87.1. And so I get 0, 1.8, 2, and 0.8. Okay, so stop and check. Do I have a 0 in every row and every column? I don't have one in this second row here, but I do in the first, third, and fourth. So now I'm going to subtract from that second row the smallest values. I'm going to subtract 0.4. Okay, so I'm effectively doing every row reduction, but obviously the smallest value in the first row is 0. So when I subtract 0, it has no change. Same with the third row and the fourth row. Okay, so just popping that in underneath here. So again, the top row, nothing's going to change because the smallest value is 0. Let's write that out. Second row, I'm going to subtract 0.4 from everything. I get 0.8, 0, 1.5, 1.4. And again, third row, smallest number is 0, so nothing changes. And fourth row, again, 0 is smallest number, so nothing changes there either. Okay, now that I've done that, I've got a 0 in every row and every column, and so I can check the lines, the number of lines that I have. And so when I go to cross those zeros out, remember if there's 4 people allocated to 4 tasks, I have to be able to cross out the lines using the least number of, cross out the zeros using the least number of lines possible. And for 4 people, 4 tasks, if those lines are 4, then I'm ready to allocate. And so there's a couple of different ways of doing it, but if I look here, if I cross out across that top row, maybe down this column here, and across the third row, and down the third column as well. So there's multiple ways of doing it, but I have to use 4 lines. So that tells me I'm ready to allocate. Okay, so if I now go back and look at where those zeros were, remember every 0 is a possible allocation. Is there any person who could only do one task? Or is there any task or distance, in this case, that can only be done by one person? And so if I have a look here, second row, Imani can only do the 200 meters. Okay, so Imani to the 200, which means that Lola doesn't need to do the 200. So that leaves Lola only one option here, doing the 300. And looking at what's left, we have Anita can do the 1 or the 400 meters, but Jordan can only do the 100. So we put Jordan into the 100 and Anita into the 400. And so there's our 4 options. And so just a reminder, you must write down your final answer into the table that's provided, not just do all that work and then forget to pop it where it's required. Okay, so now looking at question 3, we've got Fenstale High School is planning to renovate its gym, and the project involves 12 activities, and we've got our directed network below. with our completion time in weeks. So letting us know that the minimum completion time is 35 weeks. Okay, so it's nice to note so that when you do your forward and backward scan, you know that you're on the right track if you end up with 35 as your finish time. Okay, so I've gone ahead and done a full forward and backward scan and highlighted the critical path so that I should be able to answer these questions relatively easily now. Okay, so how many activities are on the critical path? So we can see we've got A, B, D, F, G, I, K, L. So that's 8 activities in total. Remember that if you have 2 options, so say when I get to the end of F, if I'm not sure which direction to go in because the numbers in the box at the end of H and the end of G are the same, it's the value that led you to put that red number, the 16 in the box, that came from activity G. So that tells me to head along activity G. Same here, it's the value from I, the 20, that I knew gave me the critical activity. Okay, so I follow I, and then when there's only one option, it's pretty straightforward. Okay, part B, the latest start time of activity E. So E, where does it start from? And the latest start time, remember, is that right hand to the red number, so that is 12 weeks. And which activity has the longest float time? So looking at your non-critical activities, so C has a float time of 1, E also 1, H is 1, J is 5, so 25 minus 20, and so therefore we have J at 5 weeks. Okay, so continuing on, the question is now letting us know that it's possible to reduce some of the completion times. So we can reduce the completion time for activities C, D, G, H, and K by employing more workers. So the completion time for each of these activities can be reduced by a maximum of 2 weeks. What is the new minimum completion time that the project could take? So here we need to apply all reductions. So we're going to reduce each of those activities by 2 weeks and see what our new completion time would be. I'm going to set this up in a table for those of you who have used the table method before and just show what happens there. Okay, so I've just set up the table showing all of the possible pathways through and the length of each of those pathways. So this is without any reductions whatsoever. And so now what we're going to do is consider in each of these pathways, every time we see C, D, G, H, or K, we're going to subtract 2 weeks from that original time. Okay, so the first thing I would do is actually just go through and highlight where am I seeing those activities I'm allowed to reduce. Okay, so in the first pathway we have C, we have energy. Okay, so that means I'm going to take 4 off that pathway. So it gives me a new time of 25. Okay, 2 for each of those activities that I've highlighted. Same thing as we're working our way through. So in the second pathway, we've got C, G, and K. And so there's 6 coming off that, which gives me a new time of 28. In the third one there, I've got C, I've got H and K. So again, 6 coming off gives me a new time of 27. Fourth pathway, I've got D and G. So 4 coming off there, new time of 26. In the fifth pathway, again, I've got D, I've got G, and I've got K. So 6 coming off, new time of 29. And the final pathway, D, H, and K. So again, 6 coming off there gives me 28. Okay, and remember you're looking for what is the longest pathway out of those reduced, and the longest is now, so a new time of 29 weeks. Okay, and so the final question that we're looking at is a continuation of this crashing. Now, as always, the most challenging part, we're looking at a cost associated with each of those activities, and the cost for each activity is different. So now we've got the 5 activities and their completion times, to have those reduced is associated with the cost given in the table. So for each, week taken off activity C, it will cost us $3,000, $2,000 for D, and so on. The completion time for each of these 5 activities can be reduced by a maximum of 2 weeks. That still holds. And now this high school wants to reduce the overall completion time by 4 weeks at the minimum cost. Okay, so we need to achieve a new time of 31 weeks and meet the cheapest way of doing it, the most cost effective. Okay, and giving our final answer there. So what I'm going to do, this is a little bit trial and error, but obviously there's some key things that we know we'll need to reduce. Obviously looking at activities that are on the critical pathway, they're our first option, and also what is going to be the cheapest to achieve that reduction. Okay, so I'll set up the table on the next page and we'll sort of work through some of our options there. Okay, so I've set up the table with just the original pathways and have highlighted the activities that we are allowed to reduce. And so just a reminder, we need to get down to 31 weeks. That's our aim in the cheapest way possible. So if I look at these 4 paths here that are currently bigger than 31 or longer than 31 weeks, they're our priority. So if we're looking at what is common to each of those, that helps us with a bit of a start point. So we can see the common activities, K in all of them. We have either G or H in them, and then either C or D. And so if I just look for a moment at my current critical path, the activities there, D, G, K, definitely will have an immediate impact. But instead of just reducing that in the combination that will give me 4 weeks reduction in the cheapest way, I'm just going to do each of those activities reduced by 1 for now and just see what impact that has on those other paths. And then I can adjust and make the best decision about what else I need to reduce. So as I said, I'm going to do G and K, 1 off each. That's a total of 3 off that path, that critical path. So checking for if any of these paths have that activity. The first path here has a G, so that will come down to 28. The second path has a G and a K, so take off 2 will come down to 32. The third path has a K, and so that will come down to 31. Fourth path has a D and a G, so it'll come back down by 2 to 28. Our critical path has 1 of each, will come down by 3 to 32. And finally, we have D and K, so come down by 2, again to 32. So at the moment, we now have 3 of those paths on 32. Okay, and we have only reduced by 3 so far. We still need to reduce by 1 more. So looking at those paths, is there anything that is common? Okay, so not out of the G, G, and K, but is there anything else? And we can see no. We've still got that combination there. So which is the cheapest way to reduce any further? So let's think about maybe H, okay, because that's one of our cheapest ones, and see what impact that has. Okay, so that will help us with this final part here. If we were to reduce D, okay, which is $2,000, that would help us with both the 5th and the 6th path, but it wouldn't make any difference to this second one up here. Okay, but it is the cheaper way of doing that. If we were to reduce G, that would help us with path 2 and 5, but it won't help us with the final path. Okay, and finally, if we were to reduce C on its own, it's not going to be helped with these ones. If we were to reduce H, it will help us with the final one, but not path 2 and 5. So it becomes a little bit of juggling, a little bit of testing out what is going to be most cost effective. Okay, so at the moment, we have spent 2,000 plus another 2,500 plus 4,000. So that is 8,500 cost us so far. Okay, so thinking about what is going to achieve that final little bit. So let's try G by another one more. So let's do G, take off another week. Okay, so again, that will bring this pathway down 27 because it has a G in it. It'll bring this one down to 31, which is what we want. Path 3 won't change, but that's okay. It's already at 31. Path 4 will come down another one. 5 will come down another one to our target. And path 6 won't change. So we just need one more alteration to get us to our target of 31. Okay, so we're there with these three, and it's just the sixth path that is still a problem. And so looking at our sixth path, the cheapest way to do that would be to reduce H because it only costs $1,000. Okay, so if we go and do that now, take H, take one off that, and so no change for the first path, no change for the second. We would get another one off the third path, no change for the fourth, no change for the fifth, and finally one off the sixth path. And so we've achieved that there. Okay, so if we add up how much that has cost us all up, I guess then it becomes that tricky juggling act of, well, which one was the better option to do? Okay, and you can go around in circles a little bit, and there is no perfect way when you're hitting when you've got, I guess, a budget in two parts. So this budget is just reducing by a certain amount, not the most that's possible. And then also the cost of each of those reductions is slightly different. Okay, so what I was able to do here, I didn't reduce C. I reduced D by 1. I reduced G by 2 in total. I reduced H by 1 and K by 1. Okay, and that gave us that cost of $12,000. We could go through looking at other options. I know that this is actually the correct answer. So it is just about having that strategy and having some time available to you. Remember, this is a 2-mark question. So there would have been some marks for identifying perhaps just the activities on the critical path and then identifying that others were needed. It depends on what the examiner's advice was for that year. And it's about a judgment. How much time do I have to allocate to this? Have a quick run through, have a first go at it, a draft at it, make sure you've completed everything else, and then coming back if you've got time to really spend sort of going through some multiple scenarios. It could be that you're just trying different combinations and comparing original to a different combination each time and knowing which combos will cost you what amounts and therefore how much, which is the most cost effective one to use. Not an easy question at all, which is why it was so poorly answered, mainly because of time, but also for those who were able to have a strategy to have an attempt, they found it really challenging. So you just got to try your best at this type of question and just keep practicing different styles so that you'll feel comfortable with the method that you have. Okay, hope that was helpful.